Hi guys, I'm just going to make a quick video to walk you through how to do a line of best fit for an exponential relationship using by hand, and then we'll do it again using technology to kind of check our answers. So if you take a look here, I've actually just created a table of values of an exponential relationship. So you can see here that's the equation y equals 2 to the power of x, and you can see the table of values. We just pick our list of x's, and then we calculate our list of y's. So this is y equals 2 to the power of negative 3. If you punch into your calculator, you get that. 2 to the power of negative 2 is that. 2 to the power of negative 1 is that. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and so on and so on and so on. So we're going to put this onto a grid. And here we have a little bit of grid paper, and let's use our ruler to create our grid lines. So this will be my x-axis. We don't need much space underneath because there's no negative y's. There it is. And we'll just do our y values up over here. So something like that. And now I'm just going to plot all of our points. So our points are, well, let's see how much space I have here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Yeah, 1, 2. So I'll do 2's for the y-axis. That'll be 2, that'll be 4, 6, 8, 10, 12, 14, and 16. And then on my x-axis, I am going to have just by ones, minus 2, minus 3, minus 4. That's positive 1, 2, 3, 4, 5. And that's enough to cover our set of points that we have here. So now I'll just plot our points. So at minus 3, it's at about 1/8. So that's 1, that's half, that's a quarter, that's an eighth. So barely above the line there. Won't actually touch the line in real life, but fat markers make for difficult plotting of points. At minus 2, I'm at 1, then a half, then a quarter, just a little bit above that one. At minus 1, I'm at a half, so there's 1, there's a half, or so. At 0, I'm right at 1, so it's halfway between 0 and 2. At 1, I'm at 2. At 2, I'm at 4. 3 goes to 8. 4 goes to 16. So there are our points, and as we can clearly see, they do not go in a straight line, not at all. So we actually have to draw a line of best fit, and what we want to do is we want to aim to go roughly between the middle of all these points. Okay, so again, we want to try and go roughly through the middle, so we're just going to, now you can't exactly go right through the middle, like it's difficult to figure out exactly where the middle of this is, but basically you want your line of best fit to be as close as possible to as many points as possible. So if we try to kind of wiggle this around a bit to maybe try and get it as close to these points here as we can without going right through the center of them, because then these points up here will be too far. So we're just going to kind of wiggle it around to try and see if we can get it as close as we can. And this is roughly, like, that looks pretty good. Let's do it from here. Now again, remember, a line of best fit is an approximation of the middle. Technology can do this a little bit better than we can, because it has calculations about statistics, about how close things are and what it should be considered and what shouldn't. But this one, if you notice, I have roughly, again, the same number of points above the line. So 1, 2, 3 above the line, and I've got 1, 2, 3, 4. Well, I've got 5 underneath the line, but you'll notice they're also pretty close, right? I've only got 1 or 2 that are a little bit further away, but most of these points are about the same distance away from the line. And that was actually my goal. We can check this using technology, using an app called Desmos. And if you actually go to the home page for the course and pull down the menu, the top, the nav bar here has a link to Desmos. So you just click on it, it'll take you right to this page. Nice thing about Desmos is you can put in a table of values. So I'm just going to put in the same table of values we used before. So minus 3, minus 2, minus 1, minus 1, and then actually predicts what I'm going to do next. And if you found your data online, it might let you copy and paste it in. I'm not 100% certain. And for these y values, I can enter in the equation itself. So 2 to the power of negative 3, and it'll figure it out. Or I can just enter in the numbers themselves. So 0.25, 0.5, 1, 2, 4, 8, and 16. So there are my plotted points. And now we can actually tell it to do a linear regression for us. A linear regression is a fancy way of saying find the line of best fit. Linear meaning line, regression meaning, well, find something that is kind of in the middle of it. So now when I actually want to do this, I just click underneath on this blank space, or I can click the plus and say add an expression. It doesn't matter which one you do, but I'm going to say y1. And now I'm not going to use equals, I'm going to use this tilde, which is next to your 1 key. Shift in that little backtick, it's got a tilde. And if you remember, the equation of a line is y equals mx plus b, so I'm going to say y1, referring to the y1 in this chart, is about equal to, that's what the tilde means, mx1 plus b. And we'll see that it's created a line of best fit for us here in purple, and you'll see it's roughly close to where we were before. I mean, it's not perfect, and you'd be hard-pressed to find one that is. And if we actually even compare it to our graph, I got about the same x and y intercepts, but it somehow passed through the left side of this top point, whereas I went on the right side of that top point. And that's okay, because we are roughly similar in terms of our lines of best fit. And the technology is obviously more accurate, but if your lines of best fit are pretty close but not exact, it's just fine, because we are doing approximations, and that's essentially what it is. An approximation is an educated guess that comes pretty close. Okay, I hope this is helpful.